Hello, my name is Andrew Jacobo, and today I'm going to present to you my project. In this project, we've chosen the dataset of COVID-19 exposure cases spanning throughout the years of 2020 to 2022. Going through task 1, we import all of the necessary libraries, i.e. NumPy, Pandas, Matplotlib, Seaborn, and sklearn. We then import the said JSON file through this link right over here, and then we basically filter out the data that we have imported. First of all, we filter out the data to the following columns: dates of interest, basically the date of the exposure, the case count, that is the overall number of cases, the death count, the overall, sadly, of course, the overall number of deaths, and the hospitalized count, the overall count and overall quantity of hospitalized events. We then drop all rows with empty variables or not numbers, and then we basically we either edit the columns accordingly. In this case, we are transitioning the date to localized UTC, and we lastly add a new column called month. So here is the data set, the data frame that we are going to be working with. Moving on to task 2. In task 2, I wish to represent the following data for further mutual understanding and linear regression analysis. Let's start off with all of the infection cases, followed with the deaths and hospitalized events. So this graph right over here. In said graph, the blue line is basically going to be the overall number of cases per date, the red line is going to be the number of deaths, and the green line is going to be the number of hospitalized events on said date. Moving on, next off I wish to represent the distribution for daily COVID-19 cases in New York using a histogram, and it's basically this right over here. Lastly, for task 2, and for our understanding, this is the monthly distribution of monthly cases. Just an interesting side note and an interesting evidence I want to put out, there are way more exposures during November and December, right over here, both of them right over here, which I guess I can attribute to the New Year's festivities and people just going out and not following simple mask procedures. Well, to each their own. So, moving on to task 3, the linear regression analysis. In this task, we are going to try to train a model and simulate an arbitrary number of hospitalized cases and events. So this is my first simulation, and as you can see on the x-axis, this is the authentic and actual hospitalized cases, and on the y-axis, this is basically the our simulated hospitalized events count. And as you can see, if we go through the theorem of least smallest squares and draw a line, we are pretty much somewhere close to the middle if we just arbitrarily look at these values. I'll look at the scatter plot. And just for our mutual understanding, I decided to draw an even better model. This next graph shows the actual hospitalized count on par with the simulated one. And looking at the overall simulated model, we can definitely say it's a definite success. Just look how, yes, as you can see, the red is the simulated hospitalized counts and the blue is the actual hospitalized counts. As you can see, look at how on par it is with a almost identical. Given the last graph, we can definitely say that the simulated hospitalized model is almost and sorry for tautology, almost on par with the actual model. Okay, thank you so much for your time. Have a nice day.